Okay, welcome back. We will now enter into one of the more complex parts and perhaps the most challenging news in the new directive, which is the safety assessment. And the requirement, as I said before, is really one sentence in Article 18, stating that before you place a product on the market, as a manufacturer, you must carry out an analysis of the 6 different hazards which are mentioned that the toy may present, and also an assessment of the potential exposure to such hazard. Now, the combination of exposure and a hazard is what could produce a risk. If there is no exposure, there can be no risk, also if the hazard is high. On the other side, even if there's exposure, but the thing you're exposed for is not hazardous, there will still not be a risk. So therefore you need to take both those two into consideration. So we could say that the safety assessment is a kind of risk assessment. And the aim of this is, of course, to identify and minimize risks. And it can be done at any point before placing the product on the market. But of course, as a manufacturer, the earlier in the process you can do it, the easier it will be. You want to assure the safety of the product rather than to control it at the end. If you can make your safety assessment at an early stage, you can also introduce the necessary changes at an early stage, rather than finishing the toy and then submitting it to testing, finding that it didn't comply, and then you'd need to go back again. So this is also one of those requirements which only the manufacturer is obliged to do. Nobody else can take it over. And I need to point out, I think, that this requirement is not part of the chemical requirements. This requirement is in place since the 20th of July 2011, also as regards the safety assessment for chemicals. So it's not going to come into force on the 20th of July, like all the new chemical safety requirements. This is already in place. There are 3 parts, or I will divide these into 3 parts. One of which is the mechanical, physical, and flammability and electrical hazards, where we do have harmonized and referenced standards that give presumption of conformity. The second group would be the hygiene and radioactivity hazards, where we have no harmonized standard and where the safety assessment is used instead. And the third group would be the chemical hazards, where we have standards in some cases, but in other cases we don't. And the question was asked before, and it's a bit difficult to explain why, but my experience is that for the mechanical and physical hazards, it has been extremely strict. That if there's any hazard which is not covered by the harmonized reference standards, you need to go through the notified body and the EC type approval. However, as we know with EN 71.9, which was never referenced and therefore doesn't give presumption of conformity, authorities do not go around asking for EC type approvals, nor do they do that for hygiene hazards. Radioactivity hazards, I wouldn't suppose so. For the CMR substances, we have around 1,100 substances classified as CM or R in the CLP regulation, and to create a standard to cover all those in testing would just be impossible. So I would say that the safety assessment is considered to be an alternative for the EC type examination when it comes to chemical hazards not covered by harmonized standards. We're not going to have testing standards for fragrances either. If you read the directive word by word, it does say that if a hazard is not covered by a harmonized standard, you need EC type approval, but that would make the whole system unworkable, because more or less every product would contain something that could be considered as not covered by the standard. So it's difficult to explain, but that's how it works. And the authorities might object if they want to, but no, probably not. It's complex. Anyway, again, there is the guidance document, and it's very sensible to try to read it, because it will contain a lot more than I will have time to speak about today. Now, what would you need in order to perform your safety assessment? Well, knowledge about the toy, of course. How is it used? Which age group would use it? Will it be used indoors or outdoors? Which materials are used? Which substances, etc. The more you know about the toy, the materials and the substances, the easier the task will be to perform the safety assessment. You need to know about applicable standards. If you are aware and reasonably well acquainted with the various standards, it will also be easier for you to decide whether your product is fully covered by those standards or whether you have introduced something which might not be covered. For the chemical side, you would of course need to be aware of not only the limit values in the Toy Safety Directive, but also the ones mentioned by Christina in REACH or in CLP or in the ROS Directive or the Battery Directive, etc. Knowledge about emerging issues. After all, the standards have been developed by a lot of people representing many stakeholders, from consumers, test labs, manufacturers, authorities, which have worked around the table to create something which would really ensure the safety of the toys. So normally it wouldn't be possible for a single manufacturer to suddenly come up with a whole new set of hazards that should have been covered. So in many cases the standards are very good and cover almost all hazards. However, the standards are always written for today's products, or rather the products that were on the market like 2 years ago, because of the standardization process. And that's why we talk about emerging issues. I always use the magnets as a good example. 15 years ago, 10 years ago, nobody had any thoughts about the hazards of including magnets in toys, because those magnets would normally be quite harmless. But then in the scientific development, suddenly the little nib magnets were made cheap and they made fun, because you could play with, you could design a car and you could mold a very strong magnet in it so it could climb up a metal leg of a chair, for example. So magnets became common in toys, and then we have the toys described from the Danish presentation where you could build things, and then suddenly one manufacturer didn't secure the magnets well enough, so during play they would fall out and children would eat one magnet, two magnets, and then they can attract each other across intestines and cause necrosis and ruptured intestines with a very acute situation. We've seen fatalities and quite a few very urgent cases where surgery was needed. But the one who first introduced those little magnets in toys, maybe he should have thought, or she should have thought, now there's nothing in the toy standard about magnets. Am I doing something now which I should think more carefully about? Could I be introducing a new hazard? And this is really what it's about, to try to think outside the standards, to try to consider, both for the mechanical, physical, flammability, etc., but also for the chemical hazards. Is there anything else that I should consider than what's already in the standards, due to the fact that I'm producing this toy where there might be new hazards not covered by standards? Then, of course, knowledge about hazards. What types of hazards do we have? And I think everybody can relate to the mechanical and physical hazards. You can cut yourself or crush a finger or get stuck somewhere. You can get strangled or you can suffocate, etc. It's much more difficult to relate to chemical hazards because you can't see them and nobody really knows what it takes. What we try to do is define an acceptable level below which you don't think that there will be any long-term effects. But also here, science is continuing and we learn new things, and suddenly those truths that we thought were a truth a while ago are not truths anymore. And that's when limit values can be revised. But the more we know about those hazards, the more we can relate to them, the easier it will be to perform the safety assessment. And then, of course, we need an ability to evaluate the risk. A risk doesn't necessarily mean that you need to redesign your toy or recall the toy. A risk is could be very, very low risk. It might be okay, but it could be a medium risk or a very high risk. So depending on the level of risk, you would need to take appropriate action. And normally when you do a risk assessment, you will have different ways of dealing with the risk. Where the first would of course be to try to design away the risk. Redesign the toy to eliminate the risk. But if you can't do that, you could possibly instead have some protective device. Like on a bicycle, you have a chain shield. You know that there's a crushing hazard between the chain and the cogwheel, but if you put a shield there, that's the second best solution, because you need the chain. There is no other technical solution. And the third option would be to have a warning. If you cannot redesign and if you cannot protect away, then you could use a warning. But of course you can't say, you can't use warnings and then justify very serious risks. It still has to be proportionate. But that's just to say that redesign will always come before use of warnings. And the standards are pretty good at specifying when you need warnings and when warnings are allowed in order to cover a certain risk. Now, even though it's the obligation of the manufacturer to make and perform the safety assessment, of course he can use third-party services. He can use consultants, and of course he can use third-party testing. The point is that he is responsible for the compilation of the file, but it doesn't mean that he cannot talk to anybody else while doing it. So yes, he can use third-party services. So let's move into the first section, which was the mechanical, physical, flammability, electrical hazards. As I said, specifically I think for this area, the standards are very up to date and they are continuously amended. You'd be amazed if you'd see all the work going on already with the 2011 version. We already have plans for quite a few amendments because new reports come in of unexpected either behavior or designs, which calls for an update of the standards. But still, they're very good and they're very up to date. And that's why we should focus on the emerging issues. But what you should do as a manufacturer is to identify the users, the intended and foreseeable use. That will determine a lot. Is it for a 1-year-old, 2-year-old, 3-year-old, or a 13-year-old? And what is the foreseeable use? And to identify the hazards. And that can be difficult. It's not always easy to foresee what the child might do, but that's what you have to try to do. Some hazards are obvious, and some are not. So the second step would be, now you've thought through which hazards there might be, and then you'll identify the applicable standards. And it's rather easy because we have 3 standards plus the electrical standards, those that would cover mechanical, physical and electrical hazards. And then you need to think again, do they cover all the hazards? And it's not the intention that you would write long essays on the subject. It's more of a confirmation that, yes, I have not been able to identify, or I have been able to identify something which I cannot find in the standard, and this is how I'm going to deal with it. And then the risk management, or your decision. Do I redesign? Can I use a warning, or should I submit it to EC type examination? Now, the particular requirements for the hazards I mentioned now are found in Annex 2. That's where we have all the particular safety requirements in parts 1, 2, and 4. And just to look at the process graphically, you identify the toy, describe the use, identify hazards, and then you walk over to the standards, which ones are applicable. Are all the hazards covered? No. Well, either risk management, that is redesign, or you go through the EC type examination. If they are covered, somebody mentioned, was it Vibeke perhaps, that there have been cases where, for example, for suction cups on projectiles, there was a special notice published in the official journal of the European Union saying that EN 71.1, the standard, was good from all aspects except when it came to suction cups on projectiles, stating that in those cases you need to have an EC type examination until the standard has been improved. Now the standard has been improved, so that notice has been withdrawn. It's quite unusual with these notices, but you should still be aware if there are any. If there are, well, you're back to the red square. If there are not, well, then you should be okay to place the toy in the market. But you should, in some way or another, document this process, because as you've learnt, you can be asked to show it. And therefore it's important to have some type of documentation. And again, the level of documentation will depend on the complexity of the toy. I cannot say exactly how much it should cover. When it comes to identifying hazards, what sources could we use? Well, you will always have your own experience. Customers might have complained. You have probably studied the RAPEX lists. You might be subscriber to recalls from the US Consumer Product Safety Commission. Maybe you're familiar with other standards which cover sometimes hazards which are not covered in the European standards. You might be a member of, you might receive newsletters from the Consumer Agency, the Chemical Agency, or other local authorities. Maybe you're a member of an association which sends out newsletters. You will be reading the guidance documents from the European Commission. Those are all different ways of, or different sources that you could use in order to identify hazards. And then you need to consider the unexpected, the unusual play pattern. As mentioned before, you might think that this toy is going to be used indoors. And then what if somebody brings it outdoors? It might not be intended to be used in water, but let's just think what would happen. Would it suddenly become dangerous if it was used in water or outside in the rain, for example? If you suddenly start using, as I said before, new materials or new concepts, if you introduce a new play value somehow, that's when you need to look extra carefully. So again, standards are written for today's product, and you need to try to think a bit further. Now, it might be, in this case, we know that for mechanical and physical hazards, we do say if the standard doesn't cover all the hazards, you should submit it to an EC type approval. How would you know? Well, actually, there's been a protocol published by the notified bodies. Those are the ones that perform the EC type examinations. It's published on the Commission's webpage, and they have a list of products for which they have been requested to perform EC type examinations. At present, there is the trampolines are on that list. They're considered to be toys, but there's no standard in place. So trampolines for home use in the garden are considered to be toys where the hazard is not covered by a harmonized standard. So it should be EC type approved. Presently, there's also remote controlled helicopters on that list, toy helicopters I should add. And there are some other products on that list. So that will give you some guidance. If you produce those particular products, you should probably think twice unless you already have an EC type approval. And of course, this is open information to authorities and to manufacturers. A manufacturer can always choose to go further. There's nothing preventing you from saying, well, okay, the standard sets a requirement of so and so many newtons or millimeters or whatever, but I want to be on the safe side. I'll try to reduce the risk even further. You can also, you will find that there are several risk assessments you need to make while you read the standard. And I'll just show some of those. Now these are all parts of the standard where the requirements are worded in such a way that you actually made to make an assessment in order to know whether you comply. The material should be visually clean and free from infestation. That's not a very precise requirement, so it's up to you to determine that. If you fail the test for a sharp edge, you should then assess whether the edge presents an unreasonable risk of injury. Because we know that some edges would fail the test and would still not be, cause the potential skin cut. Same applies for sharp points. Rigid tubes, or tubes and rigid components in the form of projections, if they constitute a puncture hazard, they should be protected. There again is something for you to assess. A driving mechanism which has sufficient power to injure fingers or other parts, that should be, in some case, well, if it does have that potential, it needs to be submitted to certain tests. If not, it's not submitted to those tests. Finally, splinters on surfaces and accessible edges of toys should not present an unreasonable risk of injury. So there are several such examples, and it's all about risk assessment, already built into the standard. I will use my own company as an example, just to show how we have tried to look a bit further than the standards. And as we produce a building system, we will try to approve every new single element that we intend to produce. Because when we approve an element, it has to be possible to use it in together. Well, the building system makes it possible to use it together with all already produced bricks. So we need not to think only of the element. We need to think where will it or where can it be used. So for each element, we perform what we call an element risk assessment. And this is at the design stage. It could be on the drawing stage already that we go through this element risk assessment. And that's all based on in our internal product safety requirements. But they, in their turn, would collect from all standards over the world and possibly other requirements proposed by NGOs or authorities, etc. It's up to us to decide what's in that risk assessment. And then for each model we produce, when we decide to launch a new model, we will also make a model review, which includes a model risk assessment, so that we don't show designs which could be potentially dangerous. I think everybody knows that, let's say illegally on the internet, you can probably find instructions on how to build very dangerous things with Lego. We of course don't support it, we would never show it, and we try to make sure that the models we show don't, for example, have a long protruding mast with a sharp edge on it that children could fall on. So we need to think, when we design a model, that we avoid any hazards, even if we've approved the element. And then when we start production, we produce a toy safety report, we call it. And that's elaborated based on real tests made on produced elements. And then we test them not to the standards, but to the breaking point, so that we know if the requirement is 100, does our component fail at 150 or 200 or 400? And then we can decide internally what margin we want. Because if something would happen one day in production, we don't want it to be just above the limit so that it can drop below the limit if something happens. We want to have a margin. And then, of course, the implementation of the internal production control to make sure that we maintain the same quality. Meaning that when we finally submit a toy to a third-party test, which we do because it's a requirement when you sell on the US market that you write a certificate based on a third-party test report, we should never see any surprises. It should always be a pass, because we've already designed the safety into the product. I don't expect you to read the details, but this is an example of what we call the element risk assessment, where we would just list hazard points, edges, protruding parts, hinges, folding mechanism, torpedo, cylinder, and then just mark off, does this apply or does it not apply? For certain risks, we would also say, well, when we launch or design a new product which is a projectile toy, we will always make a separate risk assessment. So that's our list. There's no requirement for others to have this list or to include the same requirements. That's how we decided to do it. I'll just make some examples. We have, everybody knows the small parts cylinder. We have what we call a design cup. It ends here. It's got two sides, but this side is a larger small part cylinder. It's 5 millimeters larger. And this is for the designers, so that they don't design elements which are 0.1 millimeter larger than the small part cylinder. We know that they can never design anything which is less than 5 millimeters from the small part cylinder. So that's our internal decision, to make sure that we are never close to the limits. This applies to our Duplo range, which is intended for children from, let's say, 1.5 up to 4-5 years. So this is an example of a product that wouldn't enter, or a Duplo figure, for example, would not fit in the small part cylinder. In addition, this figure, the arms rotate together, so you can never place them both in. They would always, you couldn't fit it into the cylinder because they follow each other. We know from experience and from research that children like to use animals and figurines near the mouth. For some reason, they enjoy having them near the mouth more than they enjoy having certain other elements near the mouth. So we've also laid down a requirement to use a 1.5-inch template for those particular toys. So that's about 38 millimeters wide. So that's even wider. So in this case, the figure shouldn't fit either in this one, not in the small parts or design cup, and not in this 1.5-inch template. We have an animal, but you can take off the jaw. So that's a potential release of a part from an animal. So again, that must not fit into this. Now, if we look at this flame again, it's molded in a soft material because we don't want, this will probably be standing up. We don't want children to fall on it and hurt them. Even though it's a soft material, if it was perfectly straight, that could possibly be a risk. So it's molded intentionally with a little bend, meaning that when you put pressure on it, it would always bend in the same direction. It will sort of bend away, it won't stand straight up. We produced these for many, many years without any problems, but then suddenly within a couple of weeks, long ago, I think 15, 20 years ago, we received 2 reports from different families where the child had inserted it into the ear and managed to break the eardrum, penetrate the eardrum. So that was when we took a decision together with medical experts to introduce this little collar. And it's placed, it's got a diameter, and it's placed from the end of the umbrella at the distance which makes sure that it cannot reach the eardrum. There's no requirement in the standard for potential puncturing of eardrums, and probably it's a very, very unusual incident, which is why it hasn't been considered necessary to include it in the standard. But since we got 2 reports, of course we didn't want those accidents to happen, so we introduced a simple thing to avoid that risk. Now those are all examples of internal decisions on how to go further than what the standards require, because we feel it's sensible. There's no need to take any risks or try to take any shortcuts. You will never win in the long run. Now we'll move on to the hygiene and radioactivity hazards. This is where we don't have any harmonized standards. And the requirement in the TSD is that toys must be designed and manufactured in such a way to meet hygiene and cleanliness requirements, so that you avoid any infection, disease, etc. from the toy. Now there are 2 types of hygienic risks. One would be microbiological contamination from toys containing liquid or natural materials like pips, nuts, etc. And then there's a second hygienic requirement, which is the possibility to wash or clean toys intended for children under 3. When it comes to radioactivity, I've never heard of any such hazards being present in toys, but you still need to consider them. I know that there was a small group trying to assist in writing the guidance document, and what we came to think of was if you would use a component from a fire alarm, or what you call fire smoke detector, they could include radioactive components. And if you came up with the idea to create a toy where you would use that could be a potential case where you would suddenly be using radioactivity. But again, there's no explicit expectation that these types of toys will be submitted to EC-type examination just to verify that there are no hygiene or radioactivity hazards. You're free to do so, but I do not perceive that this is generally expected. And these requirements are found in parts 5 and 6 of Annex 2. So here is the requirement in the TSD. And the action you need to take is that if you do have a toy containing a liquid, or if it's aqueous based, well then you would evaluate the possible presence of microbiological contamination. And there are different ways to do it. The notified bodies have published a document describing what methods they would use if they were asked to make an EC-type examination. You can also use methods described in either the European Pharmacopoeia or the US Pharmacopoeia. And I think those of you who follow RAPEX notifications will see that quite often we have seen soap bubble solutions being recalled due to microbiological contamination. And then we have the cleaning washing requirement, which states that all toys intended for children under 3 must be designed and manufactured in such a way that they can be cleaned. And a textile toy shall, to this end, be possible to soak wash, unless it contains a mechanism, for example an electronic device, which could be damaged. And the purpose is, of course, that before and after being washed or clean, the toy should still fulfill the same level of safety as it is supposed to according to the directive. Now, the washing is not part of the standards, the actual procedure you would use if you wish to wash your toy in order to retest it. But the notified bodies, again, have published a protocol where they propose how you could wash. There's no requirements. The requirements in the directive does not refer to machine washing. It can be hand wash. So the process would be to define first whether the toy is intended for children under 3. Because if it isn't, these requirements do not apply. But if it is, and it's a textile toy, if it's not a textile toy, that's when you need to ensure that it can be cleaned. And it might be wise, in certain cases, to supply cleaning instructions, depending on how complex it would be to clean the toy. I often use the example of a duck used in a bathtub. If it has a hole in it and water can leak in, you should ensure that you instruct parents to empty it and make sure that's a drainage hole so that the water doesn't lie there and cause microbiological problems. If it is a textile toy, does it then contain a mechanism which can be damaged? If it doesn't, well, then you must make sure that it can be soak washed. And again, if you don't supply any instructions, the consumer might expect that I should be able to wash this in 90 degrees and then tumble dry it, and it should still be safe. But if you know that that's not recommendable, you can add the instruction saying it's hand wash in 30 degrees, because the requirement is that when washed in accordance with the manufacturer's instructions, it should still be safe. So it's a way of you to sort of limit your liability, let's say, by supplying correct instructions. And of course they have to be reasonable. But if it does contain a mechanism that could be damaged, then you're back to the cleaning requirement only. Yes? There is no recommendation that I know of. So I would suppose the place where it would serve its purpose best, and that would probably be on something attached to the toy, a label, because then it would be available for a long time. But in some cases that's not possible. So, but I haven't seen any specific recommendations. No. Radioactivity. Well, in this question I think it's easier. You would ask yourself, have we added radioactive material? No, we haven't. Okay. Yes, we have. Don't place it on the market. Now to the more... Yes?
For wood.
Yeah, that's correct.
So you actually need to take into account that there could be accidents that could interfere with the safety of the products.
Yeah, I think we were all reminded also about when the Japanese accident last year that it's of course a question of where you source your materials. But it's unheard of so far. But I agree, it's something you need to consider. You can't just ignore the requirement. Now we have the chemical requirements. And the chemical hazards that we will talk about are those that regard adverse effects on human health through exposure, during foreseeable use, to substances or mixtures of which the toy is designed of or contains. So many factors to consider. And again, I will just repeat that the safety assessment is considered to be an alternative to EC type examination for chemical hazards not covered by harmonized standards, because it's almost impossible to fully test your way out of it if you want to cover everything. And these requirements are in part 3 of Annex 2. Now, we did talk about standards, and the question was also raised, well, when will we see those standards? Now, it's a problem. I mean, the directive was decided, and it's also said that after 2 years, all requirements will apply apart from the chemicals, which will apply after 4 years, which means that the standards organization need to produce standards. We were exactly in the same situation when it came to EN 71.1. It was published only just before the directive came into force, because it takes time to elaborate standards. The standardization works with consensus decisions. When it comes to chemical standards, you can't just write the standard. You need to perform round-robin tests. You need to develop materials that you know the exact migratable content of. You need to send them to several labs and see what their findings were, compare them, and maybe modify the methods, etc. So it does take time. And in both cases, both the standards published in 2011 and the standards we're expecting in 2013, the standards organization has worked at a tighter time schedule than usual, and the tighter schedule than what's internally regulated in the standards organization. However, for all these standards, of the first 6 except finger paints, we do expect the final agreed text to be sent to the CEN Management Center, that's the administrative center of CEN, around the change of the next year, between the coming new year. They will then put it in the correct template, etc., and send it out for the final vote. However, we know that during the final vote you can only consider comments of editorial nature, so there won't be any major technical changes, provided that the standard is eventually approved. So even though the publication of the actual standard won't happen until very close to the publication of, or entering into force of the directive, the texts will be available in an almost finished version somewhere early next year. And for those of you who are involved in your national standards body, you should be able to get access to those texts as soon as they're sent out for this formal vote. So that gives you a bit more time. It's of course possible to already now test for many of the elements using the old methods, just to know, if you're anywhere near the limits, or if you're non-detectable, or if you're way above. It will still give you a good indication if you feel you need to do something. Some labs will offer this service already. Some will probably charge a lot of money for it. They cannot, of course, claim that they can produce a report which shows compliance with the new directive, but it will give you a hint whether you have any problems you need to deal with very soon. But I can only agree that it's a problem that the standards will be published late, but that's what we're faced with due to the limits in the directive. So these are the standards: an update of migration of certain elements, an update of the chemical experimental set standard, also the one for chemical toys, the one for finger paints, and then two new standards, the one for nitrosamines and the one for the special games in which you're allowed to use certain fragrances which are otherwise banned, provided that you have a warning, etc. And then we do still have EN 71.9, 10 and 11, which regards organic chemical compounds. But as mentioned by Christine, our focus has been on trying to get the others into place, and then in the future hopefully revise this one, which would focus on the substances which we know have been found in toys, because it's impossible to cover all substances. I mentioned the 1100 CMRs. We can't do that. We need to focus. I think that's also what companies need to do, is to focus their possible testing in areas where it's sensible. You can't sort of cover everything. So the assessment can be used to reduce testing. It can be used to target testing. So I think it's a good thing, although it might sound complex. The ambition or the purpose of the assessment is sensible. Now, how wide is the scope of the chemical assessment? Well, the main purpose, or the major part, is to assess the likelihood of the presence in the toy of prohibited or restricted substances. That's a very large part, to check that you comply with the legislation. Or, let's say, the legislation which gives you exact limit values. However, you're supposed to cover also other chemical hazards and the exposure to these hazards that are presented by substances which are not yet restricted or prohibited, but are considered to be, let's say, undesirable in toys. And you know that legislation takes time. So just as the case is with the standards, we can only standardize what we have today. Once findings are available that a certain substance should perhaps be included for a restriction in REACH or added into Appendix C of the directive, from the point that the first idea is presented until it's actually in the piece of legislation will take a couple of years. And at some point it's commonly known that it's going to be regulated. So of course those are also substances and limit values which you should consider. So all applicable regulations and directives and additional relevant information. And again, we have the exposure. So you need to consider the exposure. The CMR requirement doesn't apply if the CMR is present in inaccessible parts of the toy. And with inaccessible, it has to be inaccessible also through inhalation. So remember that exposure must always be considered. You cannot only look at the inherent hazard of a substance. And Christina's already mentioned a couple of applicable, and I think REACH Annex 17 and the ROS directive would be the very typical examples. Now, what are the ideal conditions in order to perform the perfect safety assessment? If you have a bill of materials, it should of course only include materials that you have approved and that they are traceable. You have a trade name on it. You know that the next time this material is bought, I buy the same material because it's from this manufacturer and this trade name or number or whatever. It's not a requirement according to the directive to have a bit of substances, but it's definitely a good help if you want to make a safety assessment rather than to rely on declarations from suppliers or to test yourself through the safety assessment. So if it's possible to obtain a bill of substances, that will be a great help. And of course that bill of substances should only contain substances which have been evaluated and found. One, not to exceed any concentration or migration limit, and it's important to differ between those. You know, some regulations specify a maximum concentration and others specify maximum migration. And that they do not present an inherent hazard if the defined user is exposed. And then you shouldn't make any changes to your bill of materials or your bill of substances unless you first assess and approve those materials and substances. And that you have the SDSs available for all chemicals used in the production when required. But honestly, how many manufacturers are in this position today? Not very many. Unfortunately, many would instead have the following conditions: that they don't have traceable materials in a bill of materials. So they can't ensure that they're actually buying the same, let's say, paint or piece of textile, etc. every time. Materials are sourced based on price. Tomorrow, the textile is perhaps cheaper over there than over there, so I'll buy it there. That is, you don't have any long-standing relations with trustworthy suppliers. You don't have the bill of substances for any of your materials. You don't have any SDSs. And your suppliers and your manufacturers are not aware of any requirements that apply. So they wouldn't know if they would be supplying something which is not suitable for the European market. And you keep making changes to the product. And if you have test reports that don't really clearly refer to the product that you have or the toy that you have, there are examples of test reports which lists like hundreds of item numbers to which it's supposed to apply. That of course should be a warning signal. So it's not, there is no truth for the chemical safety assessment. And it's up to every company to decide how to best minimize the chemical risk. And every company is different, will have different knowledge, different control of their suppliers, etc. And the more control you have, as I said, the less dependent you will be on your suppliers ensuring you that everything is okay. You know, it's very common to submit declarations, could you please sign and guarantee that you haven't used any of the following substances, etc. Well, many would sign it just to be able to sell. But you really need to know that they know what they're signing. Education could be one good part. So the safety assessment is there to ensure that you carefully consider the chemical hazards of the toy, its materials, and the substances it contains that might present a hazard, it should say, to the health of the child. And you need to update your safety assessment. If you change your product, or if the standards are changed, or if the legislation is changed, you need to update it. Otherwise, a safety assessment is something you do, and then you're done with it. If you don't change anything and the legislation doesn't change, then you're okay. So it's not, for every production. But in your production control plan, you might introduce batch testing of the paint used just to ensure that it's still safe. But the safety assessment as such is not something you would repeat very often unless there are changes made. So even if there is no truth, there will be good and bad approaches. And I think the closer you can get to the ideal situation, the better it will be. And the closer you are to the worst situation, of course, the worse off you are. And I think we will learn eventually now that the more information a manufacturer can get from his suppliers, the easier it will be to claim that I feel that I'm in control. I know I haven't used anything I shouldn't have used. Now there is an approach described in this guidance document which divides this process into 3 sections. Identification, to identify which substances and material you have. To characterize them, to determine if they're in the scope of a legal restriction or a standard, or if they are suspected to be hazardous or undesired. And then you would make the assessment. Is there a likelihood? And in that case, how high is the likelihood that you would contain more than the permitted amounts of a certain restricted or banned substance, or a non-restricted substance that could mean that you are presenting a risk? So both for the prohibited and restricted, and for those which are not prohibited and restricted. And Christina also mentioned the classification system. We know classification into C, M, and Rs, but there are many other hazard classifications. It could be skin irritant, or very toxic, or super toxic, etc. And of course, if you're using substances with those classifications, that's something to consider. When you identify the substances and material, again, it's obvious that if you would have access to a bill of substances, that would be ideal. I know that it can be very, very difficult to get hold of. But if you have limited information, there are other ways to do it. You can use, let's say, worst case assumptions. If you buy a soft plastic, you don't know what it is. You should probably assume that it's PVC. And if it's a soft PVC, you should probably assume that it's been plasticized. And if you don't know, you should probably assume that it's been plasticized with something which is not permitted. And then you can start to communicate with your supplier. Maybe he can guarantee you in some way or another, not only in writing, but showing documents, I don't know. Or you could test. But you can work in a way where you would say, well, I don't know, so I'll have to assume the worst, and then go from there. You could, of course, have your supplier carry out a safety assessment. And a supplier might not always be a supplier of the whole toy. It could be a supplier of part of the toy, which you then put together as a manufacturer. Perform selective tests. Of course, one wants to reduce the amount of testing to a minimum. So only when it's needed should one perhaps enter into testing. And you can also rely on your supplier's declarations or test reports. Test reports, of course, are good if you can get them from a source and make sure that they actually apply to the toy in question. And there are also some alternatives available if you cannot get a full bill of substances. For inks, coatings, lubricant and glues, you would normally be able to get an SDS or an MSDS, as the American version is called, since solvents would have been used, and therefore there would be an SDS available. For plastics and paper, you could consider whether you could buy food contact approved plastics, food contact material approved plastics. For paper, perhaps certificates regarding lead, optical use of optical agents. For metals, of course, 71.3 would be good. Nickel release, that's a requirement in REACH. If you have a prolonged skin contact, there's a risk for allergy. So that could be something to consider if you have nickel in your metal. Your supplier could perhaps sign a certificate regarding CMRs. Those are various ways to try to overcome the problems that you are seldom able to get the full bill of substances. For textiles, of course, test certificates for azo dyes could be applicable, or even an Ecotex certification. Formaldehyde, nonylphenol. There are a couple of substances you will have noticed have been in the media. Is it? Maybe it was just me. I'll just have to speak louder. Well, if Thank you. So there are possibilities to follow. What have we seen, as I said before, on Rapex or newspaper articles, perhaps presented by Greenpeace or other organizations where they've just randomly tested and explained what they have found, that could give you ideas on what you should focus on. Whoops. Well, I was only mentioning here REACH, of course, if it's applicable, and ROS would be other things to consider, whether you could receive certificates, test reports. Now, when you come to the characterization stage, that was when we tried to find out, is the substance classified as a CMR? Is it a banned fragrance, perhaps? Would it be subject to REACH? And that sometimes you would need to know whether the toy is mouthable, whether there will be prolonged skin contact, because that will decide for certain phthalate requirements, for the nickel requirement, azo dye requirement. They would be applicable depending on how the toy is expected to be used. And then, of course, to see whether other legislation would apply. And then you need to know whether they're in scope of standards. Normally it would be 71.3, and 71.9 could also be very helpful. And only if you have very specific toys, like chemical toy experiments sets or other chemical toys, then you would have other standards, finger paints, for example. And then those suspected or undesired, the ones that are in media or under discussion among authorities, etc. And finally, the assessment. So assess the likelihood whether there could be more than the permitted amounts, or whether there would be unhealthy levels of undesired substances. So the assessment can, to various degrees, be based on either declarations from suppliers, test data, or your own evaluation of the bill of substances. And of course, the cheapest way, if you have a bill of substances, is to check, is there anything in these toys that I should be concerned about? It's more expensive to test, and it's less reliable to only have certificates from your suppliers. So I would say this is a process with room for continuous improvement. And I think it needs a new way of thinking. You can't only rely on ticking off the various headings in the standards. You also need to successively gather more and more information about your toys. That's it. Thank you.
Hello? Works.
Yeah. I think you might have a lot of questions for this issue. Who will start? Maybe too many challenges at the same time.
It's a big challenge. And as I said, I don't think you can go home and solve it today. But you should start thinking for the future. And honestly, I don't think, for example, the Swedish Chemical Agency expects you to have all this in place, but I'm sure they would like to see you have routines. How do you deal with these issues? How do you communicate with your suppliers? What you try to do to be in compliance, and also check substances which are not specifically regulated.
I still have the mic here, and who want to use it? Yeah.
I often get questions from clients. I represent a test laboratory. How old can a test report be and still be valid? What do you think?
There is no rule unless you change the product. I usually say if you don't change the product, you should still have to ensure your conformity to your production, which might need that you test certain aspects, but it might not be necessary to test to a full standard. I mentioned before that you should try to identify the critical points in the production, and for those points you might want to use a third-party lab or in-house resources to make very regular tests, depending on what the potential outcome could be if there's a failure in production, so to speak. But there's no general rule saying that a test report is not good after 2 years. But let's say an authority finds one product which is non-compliant. If you come up and say, well, I did test it 8 years ago, it probably won't have much value to them. But if you can also prove that, well, during production we've done this and this and that, and we honestly believe that this is like something produced on a Monday morning, and we've been testing another 10 samples and we cannot reproduce the same failure, that would put you in a stronger position. But as such, there is no definite rule for a test report. It needs to be justified by the product in question and the production process, etc.
I guess we all think that these new requirements are very challenging for all steps in the supply chain. When the new legislation comes into force next year, and do you have any guess how big the challenge is for us? Do you have any idea will there be toys which is more dangerous after next summer than it is now? Because today the toy, of course, should not be any risk to any child or consumer. And the new regulation, I especially think about the CMRs, to think there will be a huge difference from end of July next year, because this new requirement is now more specific, that this CMR requirements is in force.
I wouldn't say, I mean, there is no tradition in toy industry to use very dangerous substances, although in market surveillance activities sometimes they're found. Maybe you would have more non-compliant toys after the 20th of July, but that would probably, the main part of those would probably have come in after the 20th of July 2011, when all the administrative requirements came into force. And as I mentioned, the chemical safety assessment is already in force. So I know that even though there's a lot of information campaigns through industry associations, authorities, etc., of course there will be manufacturers, especially those who import and sell under their own brand, who don't realize that they're manufacturers. Because if they are, they sit with the whole responsibility. There you might find non-compliances, but I'm not so sure that we'll suddenly find that substances are used which were previously not specifically banned, because there's, after all, a general ban to sell CMRs to the general public, I think that the wording is. So, not really, but it's definitely a challenge to be more in control, because if something turns out to be non-compliant, it's your responsibility as a manufacturer, regardless of how many tests or safety assessments you've done. Obviously you failed if you place a non-compliant product on the market.
It will be a challenge to prove that you are safe, because you have to have many considerations what to test for. Do you know if there will be some more specific guide which tell us which kind of material have high risks of, you mentioned 1100 CMRs, so we can know more how to do a random spot check and not, of course, to test for all 1100 CMRs. A guide for a material kind of risk will be very helpful.
Various initiatives are ongoing through industry organizations. I know that the British Toy and Hobby Association, for example, have produced something which, let's call it a mini risk assessment, which tries to direct manufacturers, importers in the right direction, say, well, this is where we have previously found this and this, so that's why you should ask these specific questions or even test for it. We have a dialogue with the chemical agency here in Sweden, the Toy Association and also the Consumer Agency, where we discuss whether manufacturers could release anonymous test results just to show that we have in 3 cases when we tested textile, we found the following azo dyes. And in that way build up a knowledge. Whether those would be released for the generally, I'm not sure, or whether they would be. I think when the authorities are involved, they would have to be released. But if it's just an initiative taken in connection with the dialogue, maybe that would be kept with those who have assisted. But there are initiatives going on, but I can't point at any particular initiative which within 3 months will result in a long list of this is what you should be careful with material per material.
Okay.
I think we had a question here as well. So.
PVC. Will PVC for the next few years be safe? Will there be new issues in addition to phthalates?
Well, we are seeing proposals to ban more phthalates, and we have more than we have the 6 phthalates mentioned in REACH, but we have an additional 2, is it, on the SVH 3 on the SVHC list. In Denmark, there's an initiative to ban, but not in toys, more phthalates. PVC as such are considered by some not to be desirable, a desirable material, but I can't see any legislation against it. I think Jon wants to complete.
Some kinds of PVC may contain organic tin compounds that also get a requirements or migration limits in the new directive.
It's used for clearing PVC, so that could be another issue. And then of course
normally it's quoted as a stabilizer.
Okay.
If you go out and ask the manufacturers.
Okay.
And you do actually find it sometimes.
Mm-hmm. And when it comes to phthalates, of course, there are specific phthalates banned. But in some cases, if you make a safety assessment, you can conclude that there are other phthalates which are so like the ones which are banned that you shouldn't really use them. Maybe the authority would like to comment further if you foresee any further problems or regulations relating to PVC specifically? Oh, okay.
Yeah. One more question? Otherwise, thank you.
Thank you.
And I can inform you that you will find coffee and small cakes outside. There will be a break. When you come back from the break, please empty the table for all these information brochures from the Commission. We have brought them in all Scandinavian except Norwegian languages and also the 3 Baltic languages. So please empty the table. Why should we bring them back? We have lots of them at home in our office.